Great. So I'm Jeff Phillips. So we're starting round 2 of the Data Science Engineering Day. So I'm an associate professor in the School of Computing. I'm also the director of the Data Science program, which is kind of an academic program that is overseeing a lot of the efforts inside of creating academic disciplines within data science. This includes graduate level kind of for kind of computer science based and broader based, and recently some efforts in undergraduate education, a new data science bachelor's degree and some undergraduate certificates, which are kind of like minors within the area of data science. I'm also the director of Utah Center for Data Science, which is kind of a research and service center at the university, trying to kind of help organize the research among a bunch of broad faculty across the university in data science, and do some service and outreach sort of activities. So I'm going to tell you today what is data science, and so I'm going to start by trying to explain what is machine learning. So machine learning is something that you may have heard about in the news, and is really one of the key drivers of why data science as a field has become so powerful, because of what we can do with machine learning. So I think it's important to really kind of conceptually understand what this is doing. Okay, and so I'm going to try and illustrate this with a bunch of data here, where the data are these ducks and these, and also these, these alpaca. And these are kind of placed on the screen in some way, and I'm going to kind of use the information to tell me these attributes. But these have been labeled, right? So each of these pictures you know is a duck or is going to be an alpaca. And what machine learning is trying to do is, given this information that we have collected, ducks and alpacas, trying to predict a new data point where I don't know what object it is. I don't know if it's a duck or if it's an alpaca, but I kind of know where it is in this picture. And that's kind of trying to represent, it has attributes I've collected. I've collected kind of some views that maybe I just have a picture of it, but I don't have a label yet, right? And so, okay, so one of the simplest things to do is just kind of what's called a k-nearest neighbor classifier, a KNN classifier. And so this kind of looks at this nearby space of these ducks and the alpacas and say, in the nearby neighborhood, are there more ducks or are there more of the alpaca? And in this case, they're going to be more ducks, right? So I'm going to predict this is going to be a duck, right? So I'm using the data I have labeled to try and predict this new data point, okay? And actually a more common and probably representative way of what a lot of the different machine learning techniques do is what would be called a support vector machine. And what this is doing is it's trying to divide the space, and there's this line I've drawn here, and this in general is a divider of the space, a classifier, into two parts. And in this case, it's often restricted to be a linear space, a linear divider. So it's a line, and I'm trying to have all the ducks on one side and all the alpaca on the other side. You see, I can't quite do that with the line, but I've done a pretty good job. And then the idea is every new data point that falls on one side of this line, I'll classify as a duck. I'll predict that it's going to be a duck, and everything on the other side I'll classify as going to be an alpaca, right? And I'm going to be wrong on one of the labeled data points, but this happens. There could be noise in the data. Maybe that was actually mislabeled. Okay, and so this gives me a function to predict new data based on some limited attributes I've collected from it. Okay, and what's really usually going on here is that I don't just have these objects, these pictures of these ducks or these alpaca, but I have these kind of abstract, these high dimensional vectors, could be 500 dimensions, is not uncommon, of these different values I've collected. Think of you're trying to figure out your customers, are they going to be profitable or not? I've collected how much money they've spent on my website in each of the last months, right? And that gives me some sense of this data. But it could be some properties about some gene, how it interacts with something, and I turn this into some vector, right? And then this is done kind of mathematically, and just give you a little bit glimpse of this. You kind of turn every possible classifier, you score it. You give it a score of how well it's doing. And this defines some high dimensional function over this. And the SVM solution is the one that minimizes the cost. It's this red dot here that corresponds with this line in some way. And so this is what a lot of machine learning does. There's these computer science algorithms under the hood that take in the data and output a solution, which is minimizing this. Okay, and I'm not going to go into all the details of how this works. That would come if you actually got the degree in data science. But there's also things you may have heard of, like like deep learning or something like that. And these are more powerful models. They're things other than just a line that divides the space, but it could be something curvy like that. And so these are going to be harder to learn. The function I'm trying to minimize is going to be more complex. But we've developed algorithms over the last 5 or 10 years that have done a great job of minimizing these and finding solutions which work even better, right? There's more complexity to this, but this is at a very high level what's going on. It's trying to build a function, a model that predicts a new data point trained on data I've collected, okay? And this idea of taking data I've collected and I've labeled and I know something about and being able to make a prediction on new data, this is kind of a big central driver of this data science pipeline, right? So now that hopefully you have a sense of what is machine learning, I can try and give the bigger picture of what is data science, which kind of fits around this machine learning tool. Okay, and so one of the first aspects of this is this is something that is applicable not just on ducks and alpacas, but is on a wide variety of scientific and engineering and so societal and business problems. And it starts with kind of sensing the data or collecting data in that area. It could be from a website, it could be measuring some plants for botany, or the skies with astronomy, or surveys for or some sort of societal or in sociology, or kind of understanding the weather. There are lots of cases, and you need to figure out how to effectively collect data and kind of make sure you're collecting the right attributes and process this. And a lot of this has been automated. Think of when Google learned to teach a self-driving car, they drove around and collected lots of data on streets, and they completely automated this process. And then the next aspect is, once you've collected all this data, you need to store it someplace and manage it and update it and make sure you don't, if something crashes, you're not losing it, and be able to provide lots of different efficient access on this data. And this is kind of the area of data management, which is another sub area of data science. And this would often be covered, think of as like databases, which could be traditional SQL databases, or more recently, there are more kind of flexible databases and lots of new technology advancements in this area. But just storing the data does not mean it's necessarily ready for doing machine learning on it yet. There's another step, which I'll call so data wrangling, which takes kind of some collected data and somehow selects out the most relevant part and transforms it into this format so I can run machine learning on top of it, or do my statistics on top of it, right? I mentioned that machine learning often takes in data, which is these high dimensional vectors. But if I have a survey data, or I have a kind of astronomy data, it's not going to necessarily start out as high dimensional vectors. It's going to be some other format. So I need to convert the format. I need to do this in a clever, wise way, so I'm not destroying the data. I need to understand what is going on under the hood, so I'm making wise decisions that's actually making sense here. Okay, and then I can apply a bunch of these machine learning tools that I just gave you kind of a very basic intro into how these work. But then, building up a classifier is not the end step either. This might not work like I expected to do. I want to kind of slice and dice the data and see how it works on different segments of the population, or kind of understand the uncertainty that's going on here, or figure out how to present this to someone who does not know what machine learning is, right? And so visual analytics is a big tool in helping as part of this pipeline. And there's part of a feedback loop that goes with visual analytics, but it also allows you the communication skills to talk to people actually maybe making decisions in marketing or in science who may not know all of this technology, right? And these are all important aspects. And together, this allows a data scientist as someone who can encapsulate and think about all these things and then make decisions that impact science or society or so business, right? And this is kind of a huge growing relevant area. This is kind of has redefined astronomy with these big surveys of the skies instead of looking at individual stars. In genomics, they decided to build the human genome, which is kind of an aggregate of all this data, as opposed to trying to look at individual genes to understand something. They understand it in a much bigger, but it becomes much more complicated to do with that. Or epidemiology, we're understanding health within populations, especially things like the spread of COVID. This has been kind of a really interesting area of data science in the last year. And not only just in science, but there are lots of companies that this is really driving what they do. Amazon, Google, Microsoft, Facebook, any of the big internet companies you've heard of, they employ lots and lots of data scientists because they're collecting so much data from their users and their websites and their products that they need to make sense of what's going on and to make wise decisions or recommendations to make the products better and to increase the profitability. And this is not just a Bay Area or Seattle sort of thing. There's a huge tech sector inside of Utah, and there are a lot of data science driven companies. Ancestry, actually, there are lots of data science cool going on there. Qualtrics, this big kind of survey sort of company. So Recursion, mixing machine learning and genomics. Domo is kind of a business centric analytics, and so Vivint have these smart homes, but there's all this data coming off and they want to make the response time and stuff like that better. This is just touching on the surface. These are just some of the larger companies, but there's a huge industry right here in Utah for data science. And so kind of nationally, this has been recognized the last 5 or 10 years as one of the best jobs in the US. I'll show a couple things. This one does not have data scientists on here, but the top two are software developer and statistician. And that's kind of put those together, you kind of get a data scientist, right? These have been popular because the median salary is high. There's projected to be a large number of jobs, which means a lot of flexibility in finding good jobs you like, working with people you like, because there's lots of demand for this. And the jobs themselves seem to be pretty interesting and enjoyable and flexible. You can often work from home if you have to quarantine or something. You could still work from home, right? So there's a lot of perks about this data science job. The problems are interesting. Here's another thing from LinkedIn. This is just the growth from 2012 to 2017. And if you look at these jobs that have grown the most new opportunities, these are all machine learning engineer, data scientist, big data developer, director of data science. A lot of the biggest growing jobs have been around this data science industry. This is from Glassdoor, which has kind of a site that aggregates a bunch of salary and satisfaction about jobs, and data scientist has been like the best job for the last 3 or 4 years on here, right? Based on some sort of objective metrics, hopefully objective. But a lot of related jobs have been kind of quite high in this area with a pretty high base salary of 110,000. Okay, now a lot of these jobs are in Bay Area and Seattle, where the cost of living is higher. In Utah as well, there's also a lot of jobs. This is from the Utah state government puts together this site. They said there are on average about 30 plus annual new openings in data scientists. So it's a growing area. And based on where our students go, this is very believable to me. And the median salary of these openings is between 90 and 110K. So this is not just high salaries because you're in the Bay Area, you get high salaries here in Utah as well. And I know this is the median. There are some salaries which I've heard from students which can go much, much higher than this as well. So this is a great area to be going into, and I have no hesitation in recommending students, try and get this work in this major because there's lots of great opportunities for them. Right. So, okay. So I want to say one more thing about data science, which I think is important, kind of a newer, more newly realized aspect to this. And so when doing this pipeline, maybe you're looking at one part of it as a data scientist, or you've been asked to do this by a company and you kind of go and do it. But I think more and more people are saying, wait, is this okay, right? What I've done, I've automated this decision for loans or student applications. Is this an okay thing to do? And there's a bunch of new ethical questions in data science that have come up because it's automating some things and that's relying on some information, and maybe we shouldn't trust that. So let me try and explain an example. Okay, let's go back to our machine learning example and our support vector machines. And we made a decision based on alpacas and ducks, right? And this seemed harmless, but maybe there are two types of alpacas. There are California alpaca and some Utah alpaca. And let's say the California ones are there are just more ones in California, right? So there are more of these. And this has caused the support vector machine prediction to change, just because I haven't really changed the underlying distribution of attributes, right? And how that should influence the prediction. I just have more of a certain type, but this has changed my classification. And maybe I actually did better on this cost function I had, but if I don't think of this as a cost function, but I think of this as a particular data point, now for this black data point, the decision has changed from the old one to the new one. And if this wasn't about duck versus alpaca, but this was about, should I accept them to college or should I reject them I should not admit them from college, right? This becomes a more important decision. Maybe I need to be more careful than just following this abstract cost function, right? Just hard to understand. Right? So we need to have this kind of deeper understanding of what is going on and how these kind of mathematical processes are making these decisions in order to kind of be fair to kind of, different groups of animals in this case, but it could be other aspects of society. So this is becoming a really important thing. And so, our goal at the University of Utah is to train data scientists who are not just skilled in the technical side, but are able to think through these decisions and to make wise and informed and fair decisions, if possible, when working as a data scientist. Okay, so a bit more, and feel free to ask questions at any point here, but a bit more in the detail of what we think of as a data scientist. This is kind of how we've designed our programs, and this is based on it's a fairly new area, right? This did not exist when I went to college. When I started as a faculty at the university, there did not really exist data scientists as an academic field. It was kind of a research area, but not an academic field. And so this is kind of developed, and there have been reports, and we've been studying this locally as well since before these reports came out in, say, 2016. But there are kind of four areas here. First one is kind of effectively manage and process and compute on a wide variety of data types, right? And so this is really, how do you take this different sorts of data and process it efficiently, store it, make sure you have efficient algorithms that handle it. And this is really captured with the computer science fundamentals, right? So this is a degree close to computer science in some ways. Okay, it's also to apply probabilistic and statistical thinking and analysis. Okay, so you need to be able to think about statistical models of what's going on. You often think of you've collected data, but this isn't all the possible data out there. This is a poll or a sample of the data, and you need to kind of fill in this thinking with probabilistic and statistical thinking. There's noise and randomness in here. And so this is also a degree related to probability and statistics. But it's not just that. You can't just be just a technically skilled person, although there's lots of cool aspects in those areas. But you have to be able to take an abstract task or data set and figure out how to perform the right data analysis on here, right? So this is related to these newer areas of data wrangling, or this ethics of data science, or the kind of in data mining, the transformation of this data to make the right decision here, right? And this is kind of a challenging newer task. It's not as formulaic as you may have learned in a kind of a high school mathematics class or something like that. You have to do abstract thinking here. And then the fourth area is to be able to meaningfully interact with some sort of technical domain experts. This could be in engineering or science or in society or in business or marketing. You have to be able to kind of interact with these people here, right? And that, you should develop some understanding of their area, and you need to be able to communicate this technical aspects of data science as well. So these are kind of the core skills here. And we've kind of, just to kind of give you a placeholder, we've kind of translated this into these 4 core classes: databases, machine learning, data mining, data visualization, which we have taught at the intro graduate level here for at least 10 years, sometimes a bit longer, but they've kind of been solidified and refined for about 10 years. But we want to kind of make this accessible to undergraduate students, and students have been very eager to take these courses, but how do we get them prepared for this? And thinking about this has grown into this bachelor's of data science. And so kind of the 2 core obvious aspects are they need kind of a software engineering stack. You need to be able to understand how to write code, to write processes, to actually make this sort of stuff happen, right? So the automation aspect of this is not kind of a challenge. You learn some of the computer science skills. Also, there's some core math that's needed: calculus, linear algebra, which is really the language to talk about a lot of the underlying algorithms here and the processes. They're described in these mathematical terms. So this is becoming essential as well. There's probability and statistics, which is beyond that aspect of mathematics. And this is kind of should be, hopefully make that point clear. But then we've added a few other classes as well to help ensure that when the undergraduate students are able to try and get to these, they're at a right foundational level. One is a new Foundations of Data Analysis course, which is kind of filling in this kind of understanding these abstract mathematics to apply it to the right sort of data and thinking to be able to do well and understand the core of machine learning and data mining, and give a basic kind of introduction to those areas. And an ethics of data science class, so you're solving problems, not so creating problems here, right? And then at the core of this is a new data wrangling class, which is an early part of the degree, which makes you very familiar with these kind of fairly simple, but otherwise not taught tools that are really the glue that holds everything together. How do you transform between one phase of this data science pipeline into another? And this data wrangling class teaches you all these cool tricks of how to manipulate and scrape data to make this happen very easily. Okay, this is kind of a technical view of what's going on. And when you describe someone, these details may make sense, but this is not at all the only aspects, right? You need to be able to talk and work with people in other domains. So we ensure that every student will take at least 3 courses in some other domain, whether it's geography or biomedicine or astronomy, where they can get access to working and learning about these domains, so they have some sort of grounding on what these techniques are doing and how they, whether they're easy or challenging to translate into these other areas, and to start learning the language of something other than just the technical skills. I think this is essential. And also they'll have to do a capstone project, a 2-semester project, or they could do a thesis, which kind of is kind of a demonstration of how to put all these skills together. There are projects in these courses, but this is kind of a nice couple semester project to kind of showcase everything they've done. So they have a grounding, not just in the technical side, but are thinking about how to apply this in the right way to some aspect of society or engineering or science. Okay, and there are some courses under the hood here. I want to mention one other thing. A lot of you are here for Engineering Day, and there are a lot of other majors you're considering. And so this data science degree just started last fall, 2019, and we just are getting the first majors into this. We started this fall, we started a new undergraduate certificate in data science, which is kind of like a minor, which is meant to take this with one of these other majors. And so this has kind of the basics of the math and the wrangling and the foundation. So you can do the basic stuff within data scientists. You may not be as skilled as a full-fledged data scientist, but you'll have all this breadth of other knowledge in this domain, and that may be even more important here. So there are classes under the hood. And so we really think this would be a great fit for majors, other engineering majors, computer science. We expect a lot of computer science majors to get this, as well as other engineering. Just this week, I've been talking with people in mechanical engineering, and they're going to create an emphasis. We're going to create an emphasis which would essentially replicate this, so their students would be able to figure out the easiest, most kind of fruitful way for them to get this data science certificate on the way to becoming a mechanical engineer as well, right? So this is something that should integrate well with these other majors, which are already taking like this mathematical or probably programming background, but thinking in a different way. And this will help them kind of translate that to think about kind of the data science aspects and become kind of this, being able to make these data-informed decisions within this sort of domain. Okay, and we've identified a bunch of courses. These doesn't include a lot of the engineering ones so far, but they're, okay, so if you want to find more information, there's a website. It's the cs.utah.edu website for the computer science /BS in data science. There's an email you can send an email to here, ds-ugshelp@cs.utah.edu. This will go to me and a bunch of other kind of academic advisors, and we'll be able to get back with you for more information. Or this is the end of the talk, so I can open up for questions now. So I will take questions from anyone in the audience.